Hey guys, Joe here. So I've been working with Howard, like he said, for a long time. I represent one of those boxes in that previous slide, one of the ingredients in the data on hardware. Happy to be here. A lot of people don't know who Solidigm is, so I appreciate the opportunity to kind of reintroduce ourselves to you guys. And I'm going to talk a little bit about one of those hardware ingredients. Maybe get a little bit geeky for you guys on SSDs. Hopefully, share something maybe you hadn't heard before, and I'll try to do that in less than 10 minutes. But as a quick intro, so Solidigm, let me advance this. All right, here we go. Okay, Solidigm. So Solidigm is really the result of the Intel's old SSD division that was purchased by SK Hynix. So SK Hynix purchased the old Intel SSD division, formed a new company. We call it Solidigm. But Solidigm today is still selling Intel branded SSDs. So I think most of the SSDs, if you cracked open a data on server today and looked at what SSDs were inside, you'd see P5520s with Intel logos on them. Those are being sold by Solidigm today. I was at Intel 21, 22 years, and then we formed this Solidigm thing. So a long-time Intel guy here. But what I wanted to do today is kind of plug our latest and greatest SSD that you might start seeing in data on servers moving forward. And I like to think of it as it's the evolution of the technology, and so it kind of touches on this TLC to QLC transition. So I want to kind of maybe educate you guys a little bit and try to dispel some myths about QLC. And also, the way I would position it is that, okay, so this new drive, I like to think of as sort of the little brother to, or younger brother to 5520, and we're calling it the 5430. Obviously, as you can see here, it's carrying the new Solidigm logo. So all of our new drives that they're going to be shipping moving forward will be branded with the Solidigm logos. So we'll be shipping both Intel Solidigm drives. But the thing here is that this being the latest and greatest technology, the latest and greatest SSD ingredient for mainstream systems. There's a lot of vectors that you can knobs you can turn and trade-offs you can make with regards to, capacity. Everyone wants big capacity, low cost, high performance, high endurance. And there's levers to turn for there's knobs to turn for all of those vectors. We like to think that this drive really hits a very, very sweet spot. And the reason why it hits that sweet spot is because it is based on our latest QLC silicon. And its bigger brother, 5520, is a TLC drive. But what I want to kind of show you guys today is that, hey, there's no need to be worried about QLC. In the past, some have thought that, the trade-off is something that they wouldn't be willing to do with regards to endurance and performance. So I want to try to dispel that myth a little bit and show you that, why this drive is an excellent fit for mainstream hardware, mainstream workloads. So getting a bit technical here, diving into the technology, how are we storing these bits? These images represent kind of like a cross-sectional view of the chips that are in your SSD storing the data. We call them the NAND chips, right? And what you see in the middle is an array of a 3D array of floating gate transistors. So think of those as little memory cells, okay? And when we talk about TLC versus QLC, what we're talking about is the ability to store 3 bits per cell or 4 bits per cell, triple level cell, quad level cell. You do that by storing by reading multiple charge levels in one memory cell. So if you can charge it up to 9 different charge levels, you can store 3 bits per cell, or 16 separate charge levels in that same memory cell, you can store 4 bits per cell. And this sounds a little bit braggy, but I think starting with Intel and now with Solidigm, we do believe that we have the most advanced QLC silicon, the most mature QLC silicon. So in 2017, we launched our first QLC generation on our 64-layer 3D NAND, and we've evolved that to now be shipping on our 4th generation of QLC silicon. It's our 5th generation of 3D NAND, where we started adding layers instead of just shrinking the transistors. But this is our 4th generation of QLC built on 192-layer NAND. The more layers you can stack in the silicon and the more bits you can store per cell, the lower you can drive that cost down. So we feel like, you know, with QLC, we're on the cutting edge of driving down cost, which means value for end customers. But we want to do that in a no compromise sort of way. So at the NAND level, if you go and read articles about TLC versus QLC, you'll read about PE cycles, what the NAND is, when you're, the way you wear out SSDs is by writing to them. And every time you write to NAND, you have to erase part of it. So that cycle of erasing and rewriting and pushing electrons across an insulator wears out the drive. And NAND is rated by PE cycles. A lot of people will tell you QLC NAND is 1,000 PE cycles, but ours, we're working with 3,000 PE cycle NAND. And so our QLC NAND really is very close to TLC when it comes to its endurance capability. And we feel like we have the most highly endurant QLC. So, you know, all of this hopefully translates to minimal trade-off and even advantages versus QLC when you're using the latest TLC drives, all while being, you know, a little bit lower in terms of cost. So one thing to kind of, one thing I wanted to point out, you guys, many of the guys on this call, you know, Andy, Benjamin, Howard, you guys are all a little bit more experts when it comes to the actual workloads that are being run. But what we encourage a lot of customers to do is use some of the tools we have available to look at what their storage characteristics look like. You know, what does their workload look like from a storage perspective? So what's your percentage of reads and writes, sequential versus random? And, you know, based on that workload, how quickly might you wear out a drive? And one thing that we've found, and there's a lot of folks writing about this in the industry, people are overbuying in terms of endurance. Modern workloads are becoming more and more read intensive, and the average enterprise workload, or 94% of the enterprise workloads right now, are kind of operating at a 78% read, 22% write type of mix. Okay, so it feels like workloads are becoming more and more read heavy, especially with some of these modern workloads. This is kind of like a shocking stat, but 99% of SSDs only use 15% of the endurance of the lifetime of the drive. So we always rate our endurance over 5 years. But if you look at, if you did the calculations, and if you're running an online transaction processing, at workload, the amount of drive writes per day that you really need are much, much lower than a lot of people think. Your drive's probably going to last 15 plus years. And by the way, this 99% of the drives using 15% of the user life, that's also given the fact that over 80% of the drives in the world are rated at less than 1 drive write per day. So we're not talking about high endurance drives. We're talking about standard vanilla drives are not using most of the life. So there is room. So the point here is there is room to take one of those dials and maybe turn the dial down a little bit from an endurance perspective. So maybe you can make that slight trade-off, to make versus maybe TLC, and to take advantage of the cost savings that come with QLC, right? So this is a little bit of how the sausage is made with the SSD and what trade-offs we make. But we wanted to kind of show you what this 5430 drive, again, 5520, which is in most of the things today, we like to refer to as the most advanced TLC drive out there. So, if there's any concern, we have got 5520. But really, if you want to maximize your value, we've been promoting 5430. And with 5430, we will based on QLC, we will actually outperform a TLC drive in a lot of in some vectors. Like read performance is better than TLC, than a lot of mainstream TLC drives out there. You don't have any compromise on read with a QLC drive. Your write performance will admittedly be a little bit lower because the way you write to a QLC drive, you have more charge levels, so you have to make sure you hit that exact charge level. And so, you know, the write performance does go down a little bit compared to a TLC drive, but, you know, is it good enough? You know, we would say probably. And endurance, the endurance does tick down a little bit from a drive write per day perspective, but we feel like the right way to look at endurance is in the total petabytes written for the life of the drive, because drive writes per day doesn't factor in, you know, how big or small the drive is. So if you look at it from a total petabytes written over the life of the drive, 5430, you know, beats its competitive TLC drives out there, given that, you know, we'll have capacities up to 30 terabyte. We're already shipping the up to 15 terabyte version, but the 30 terabyte version of 5430 will be shipping pretty soon. So max capacity is, you know, we can more easily build these larger capacities given the density of QLC. So it's bigger, it's even faster when it comes to TLC. It's actually, when you look at petabytes written, higher than the highest petabytes written you can get out of a competitive TLC drive. And yeah, the write performance might go down a little bit, but again, we feel like we've struck the right balance here. And so we're excited for this SSD to kind of be inside, you know, data on servers, because again, it's the cutting edge. And again, it should allow data on to pass on some of those savings to end customers, because the media that's in the drive is a lower cost media versus TLC. So it's just the latest innovation for SSDs. So